Hello, this is a series of video which will describe the use of the MicMap tools. There will be, I think, 5 videos in total, at least that is what is planned now. The first one will explain how to retrieve the tools from GitHub and other places. The second will be a startup example, quick example how things organized. The third video will explain where we can get some real data to do some tests. The fourth video will explain a bit how to perform somatic variant detection, and the fifth video will explain more about visualization. All these tools are command line tools, so you can do it in your terminal. And so to get started, I will show you how it is on GitHub, that the tool should be retrieved from GitHub. So in the window here in the bottom, I will have in an editor the links and the commands that I will be using in the shell, so you can also open this file in an editor or somewhere in the browser, and so you can copy paste the commands or the link from there. So let's get started. I will copy this link and we will switch to a browser window, and let's paste the link there and go to the GitHub site. So that's the project MicMap. The file I will have open in the editor is this one, this example.md. So if you click it here, it will be nicely displayed with titles, etc. and pieces, so you can either look it from here or you can get it in an editor, but then of course it doesn't look quite as nice. The package, the files you need to download, so to make things easy, we have prepared a container to put the tools where it is already installed with accompanying tools, so it's much easier to get started with this. You're of course welcome to get the source code and compile it yourself, but maybe for starters it's easier if you get the container. So to do that, you go in the Releases tab, and then you have some explanation about the current release, and the the necessary bits are in the asset subsection. So you open this, and there you see this micmap.cif, which is a singularity container file. So this is what you will need to download on your computer to get things going on your machine. If I go back here in this example.md, I have put some explanations how the container was built in the first place. So I started from a Docker image of a latest Fedora Linux release. I chose Fedora simply because I happen to know this better than the other sort of releases and feel more comfortable there. So if you end up building a container yourself, of course you can choose the one you feel most comfortable with. So this will just build basically an empty container, and then the tools can either be added from outside of the container. So here I gave it as example the way I compiled and installed the MicMap tool itself. So it's pretty much usual. You set up a separate build directory because this tool now uses CMake as a build tool. So you make a build. I happen to use the Intel compiler. It's not necessary. You can also use GCC, but since I wanted to see what happened with Intel compiler, that's how I do it here. So of course then you have to tell CMake that you want to use ICC as your C compiler. This is the invocation. I then use CCMake itself to review the default setup, and normally, for example, for the Intel compiler, I causes it to link some of the Intel libraries as static, so that's why I edit slightly the default make file. It's not necessary that you do it, especially if you use GCC. And then it's the make and make install, and since in this case I wanted the binary to be installed within the container, then I specified this here this way, and then it goes into user local by default. If you want to install other tools, you can also do it from within the container itself, so you just put it in writable mode and you have the package manager available to install other packages, or you can from within there compile other things. And when all is ready and set up the way you like, you need to be root to do the building of this CIF file itself. It tried to do it from my username, but it ended up not working. I must say that also in some cases when I, for example, install packages from within the container, it also tends to work better if you do it from the root account than if you do it from your own account. I'm not quite sure what the deal is, but anyway, that's what I noticed. With containers, you can edit various configuration files of those containers, and if you want I tend to use VI to edit files, and if you want to have a syntax coloring of the files, you can also retrieve here the specifications for VI, how to highlight those files. So I found that useful. I put it here. Then from your part, what you will need to do if you want to run it on your machine, you go, for example, in TMP and you retrieve this CIF file. I'm not sure this link might change. You better go look for, as I've shown you before, from the releases, but I think at the moment it works, but maybe at some later point with different releases it will not work as well. Another thing, if you want to use the MicMap tool itself, you will need to have huge pages activated in your machine. So that's what at least that's what we end up putting in on our machines as kernel parameters. So you need to have both 2 megabytes and 1 gigabyte huge pages, at least a certain number. You can put more probably if you like, but that's the sort of minimum we had to get it going. And once you've done that, of course, you need to reboot your machine so that things are activated. And you also need to mount. I haven't really found, you could put it in a startup files, but I just do it by hand after I reboot the machine. So you have to cause this huge page file system to be mounted and to be accessible to users. So that's the command I have. And one other thing, well, when you run things that take a long time, of course, I recommend to either go using Tmux or Screen so that you can, if your session gets cut by a network issue, you can reattach to it using either of these commands, and then that's one possible way to start the container itself. One thing to note about the huge pages, it's like TMP. Everybody can write to it and can then remove his or her own files. If several people end up using this tool, then care must be taken that the previous user removes the file he put there before finishing, so that the next user can load their own file there, because otherwise they might end up overlapping, and it will not work this way. The last bit I want to mention, if we go back to the releases, with the tool you will need a few definitions or reference genomes. For example, if you want to map reads onto the human reference genome, so we have provided several set of files that are prepared to run with MicMap, and you will find them again if you go to this releases tab. There is a link here with the set of tarballs, and I installed them in a specified directory on our machine that I will show. For this, I need to go back to the shell. So here we are. This we have seen. So just to show what happens. So if I copy and here paste, so that's when we are in the container. You can see what file systems are available, like this, for example. And the place where we put this reference data in our setup is /data6. So if I go into this data6 B38, there is, well, in my case, there is probably more file than will appear in your setup if you download it from the website, but a few important files are these b38.bin.config, fasta, and also some reference if you want to analyze RNA-seq data, which are files like this, which you will need. So B38 is the human genome version 38 with some extra decoy sequences. Basically, it's the one that seems to be typically used in other projects. So HJ38 plus some other data that is useful to clean up basically the mapping. So I think that's it for this first video. So hopefully see you in the next one.